Welcome to all of you in the class of fluid mechanics and hydraulic machines. In the today's session, we are going to discuss about the pipes in series and parallel. Pipes in series. Pipes in series, also called the compound pipes, is defined as the pipes of different length and different diameters. Different length and different diameter connected end to end in series is called the pipe in series. You can see here, this is the pipe 1 having length L1, diameter D1. This is the pipe 2, this is having the length L2, diameter D2. This is the pipe 3 which is having the L3 length and D3 diameter. So all three pipes are having a different length and different diameter, and they are connected end to end in series. So this combination is called the pipes in series. So that is the end, each pipe is having the two ends, first and second end for pipe 1. For pipe 2, this is the first end, this is the second end. For pipe 3, this is the first end and this is the second end. So pipe 1 second end is connected with the first end of the pipe's second. Similarly, second end of the second pipe is connected with the first end of the next pipe. So there is the end to end connection. So this combination is called the pipe is connected in series. This is also called the compound pipe. Each pipe may have the different friction coefficient, friction factor, or it may be the same. It depends on the pipe material. So here pipe 1 is having the F1 friction factor, pipe 2 is the F2 friction factor, and pipe 3 is having the F3 friction factor. And these pipes are connected in the two tanks, tank A, tank B. And difference in the tank A, tank B water level is capital H. So L1, L2, L3 already defined. Length of the pipe 1, 2 and 3. D1, D2, D3 is the diameter of the pipe 1, 2 and 3, and velocity in the pipe 1, 2, 3 is the V1, V2 and V3. F1, F2, F3 is the friction factor or coefficient of friction in pipe 1, 2 and 3. A1, A2, A3 cross-section area of the pipe 1, 2 and 3. Capital H is the difference of water level in the two tanks, that is the total head loss, and Q is the flow through the pipe. That means the whatever the flow is coming in the pipe 1, the same flow will go in the pipe 2 and the same flow will go into pipe 3. So the discharge will be same in all the pipes. This is the characteristics of the pipes connected in series. So discharge should be same in all the pipes. So when the pipes are connected in series, so discharge in the pipe 1 Q1, that should be equal to discharge in the pipe 2, that should be equal to discharge in the pipe 3. Discharge in the pipe 1, we can write A1 V1. Discharge in the pipe 2, you can write A2 V2, and discharge in the pipe we can write A3 V3. So all these three should be equal. Now we want to compute the total head loss. How the total head loss is given? We can see the diagram previous. Here pipe losses are, that is the major and minor losses are there. So when the fluid is flowing through the pipe, there is the losses of the energy or losses of the head. So here head loss at the entrance will be there, then because of the friction head loss will be there, then here due to sudden contraction head loss is there, then here due to friction in between the pipe, then here sudden expansion head loss will be there, here in this pipe 3 due to friction in between the pipe, and here at the exit loss of head is there. So we can combine all these losses. This is the losses at the entrance, this is the losses due to friction in pipe 1, this is due to the sudden contraction, this is the in pipe 2 because of the friction loss, this is sudden expansion due to sudden, this is due to the friction in the pipe 3, and this is at the exit of the pipe. So all major and minor losses are combined to get the total head loss. If you neglect the minor losses, then this can be removed, minor losses can be removed, and only the losses because of the friction will be there. Further, if the consider F1, F2, F3, that is the friction factor in pipe 1, 2 and 3, all are same and that is equal to F, then this is equation can be reduced to this equation, that is H equal to 4FL1 V1 square upon 2GD1 plus 4FL2 V2 square upon 2G2 plus 4FL3 V3 square upon 2GD3. So H can be written in terms of this. So this is how you can compute the total head loss in the pipe, in a pipe which is connected in the series. Now coming to the equivalent pipe. When the pipes are connected in series, then we can replace this, suppose tank A, tank B is there, pipe 1, pipe 2, pipe 3 is there. So this pipe which is connected in series can be replaced by a single pipe, that pipe will have the same diameter from start to end, that is called the equivalent pipe. This pipe is called the equivalent pipe. That means, you see the previous picture, if this pipe in series is replaced by a single pipe, so that single pipe will have the same diameter throughout. So that single pipe is called the equivalent pipe. That is the equivalent pipe. So this equivalent pipe is defined as the pipe of uniform diameter having head loss and discharge that should be equal to the head loss and discharge of the compound pipe. That means the head loss, this one is the, it is having the uniform diameter, and second is the head loss and discharge equal to the head loss and discharge of the compound pipe. So whatever the head loss is there in the compound pipe, that is the pipes connected in series, the same head loss will be from the equivalent pipe, and whatever the discharge is there in the pipes in series, the same discharge should be there in the equivalent pipe. That is the characteristic. Three characteristics is there. One is the uniform diameter, second is the head loss should be equal in the equivalent pipe and that pipe connected in the series, and third one is the discharge, that the discharge should be the same discharge, whatever the discharge in the pipes connected in series, the same discharge should be in the equivalent pipe which is replaced. So uniform diameter of the equivalent pipe is called the equivalent size also of the pipe, and the length of the equivalent pipe is equal to the sum of the length of the compound pipes. So that is also one of the characteristics, that is the length of the compound pipe should be equal to the length of the pipes connected in the series. Sum of the pipes which are connected in the series, sum of their lengths, that should be equal to the length of the equivalent pipe. That is about the equivalent pipe. So now how to give the expression for the equivalent pipe. As you know, pipes connected in the series, A1 V1 equal to A2 V2, that is equal to A3 V3. So after neglecting the minor losses, you can write total head loss, that is equal to sum of the major losses. This is the example for the pipe that is given in the previous case, that is the three pipes are connected. In the pipe 1, this is the head loss in the pipe 1 due to friction, head loss in the pipe 2 due to friction, and head loss due to pipe 3 in the friction. So three pipes are connected, and for these three pipes one equivalent pipe will be we are placing. So this is the again expression, that is the for the when F1, F2, F3 are same in all three pipes, that may not be same. Now this is the total head loss. Now if you take the single pipe, then the total head loss can, for this pipe the head loss can be written as 4FL, the length of the pipe V square upon length of, if you assume the length is capital L, 4FL V square upon 2G D. D is the diameter of the pipe. D is the diameter of the equivalent pipe. D is the diameter of the equivalent pipe. F is the friction in the equivalent pipe. L, capital L is the length of the equivalent pipe, and that length should be equal to the L1 plus L2 plus L3. That is the length of the pipe 1, length of the pipe 2, length of the pipe 3. So we can write that is equal to 4FL V square upon 2GD. So here 4F will be cancelled out, 2g will also be cancelled out, and this here velocity whatever is there that will be replaced, and the final equation can be converted into the this L by d5, that is equal to L1 upon d1 5 plus L2 upon d2 5 plus L3 upon d3 5. So we are coming to this equation, but however the basic concept is the all three pipes is replaced by a single pipe. That may be the two pipes, there may be the four pipes. So equivalent pipe concept is the length should be the same, head loss should be the same, discharge should be the same. This is about the equivalent pipe. Now coming to the pipes in parallel. Pipes in parallel, that means the when a main single pipe in the upstream is divided into two or more branches, a single pipeline will be there, then it is going to divide into the two or more branches and again join together downstream to form a single pipe. Then the branch pipes are said to be connected in the parallel. So here you can see the main pipeline is there, it is branched into the three pipe 1, 2 and 3, and these three pipes again here connected together and becomes a single pipeline. So this is the connection pipe in series. So some characteristics will be there for the pipes in series, we will see that one. So here the sum, that is the discharge, whatever discharge is coming in the main pipe, that is going to divide it into the 1, 2 and 3 pipes, then again in the coming here in the downstream the same discharge will be there. So this discharge can be written as sum of the discharge in the pipe 1, discharge in the pipe 2 and discharge in the pipe 3. This you can see here, Q total equal to Q1 plus Q2 plus Q3, and this is the important one second, that is the head loss in the pipe 1 should be equal to the head loss in the pipe 2 and that should be equal to head loss in the pipe 3. That means the whatever the number of pipes are there connected in the parallel, in all those pipes head loss should be same. That is the one of the main characteristics of the pipes connected in parallel. So head loss should be same in all the pipes. So here we are having the two equation. One is the Q, that is equal to Q1 plus Q2 plus Q3. Q1 you know A1 B1, Q2 you know A2 B3, Q3 you know A3 B3. Now second is the this one, that is HF1 equal to HF2 equal to HF3, that is the head loss due to friction in the pipe 1 should be equal to the head loss due to friction in pipe 2 and that should be equal to the head loss due to friction in pipe 3. So you can equate all these three, that is the 4FL V square upon 2GT for 1, 2 and 3. From here you will get one equation, and from first discharge, that is the total discharge equal to sum of the discharge in the all the pipes. This is the one equation, this is the second equation. With the help of this equation you can find the whatever the asked in the question, like the discharge in some other pipe or the friction factor or the length of the pipe, like that. So for example we can see the numerical problem that is based on the pipes in connecting the series and parallel and equivalent pipe. Here is the three pipes given, length 800, 500 and 400 meter, diameter is given 500, 400 and 300 mm. So these are connected in a series. These pipes replaced by a single pipe that is having the length of 1700 meter. So this 1700 is equal to 500 plus 800 plus 500 plus 400, you will get 1700. So find the diameter of the single pipe, that is the equivalent pipe. So you can use the formula, this is D1 5, L2 D2 5, L3 D3 5. So here L1 L2 L3 given, diameter also given, capital L, that is the length is also given, only D you have to compute. So from using this formula you can compute how much diameter is required to replace the pipes connected in the series by a single pipe, that is the equivalent pipe. You can find out. Similarly this question, this is the question for a pipeline divided into the two branches, two parallel pipes. So these pipes connected in the parallel. Length, diameter of the parallel pipe is given, while the length and diameter of the second pipe is given, find the rate of flow in the each parallel pipes. Total flow, main flow is given, Q is given. We have to find Q1 and Q2. So you know the two equation. One is the Q equal to Q1 plus Q2, and second is the HF1 equal to HF2. HF1, that means the 4FL V square upon 2G D. We can put the 1 here, that should be equal to 4F2 L2 V2 square upon 2G D2. So all the values are given. By using these two equations, you can compute the Q1 and Q2. Q1, Q2 you also know, that is A1 V1, A2 V2. So using these equations, you can compute the discharge Q1 and Q2. So try this question. So this is for the today's session, that is we have discussed about the pipes connected in the series and pipes connected in the parallel. Also discussed about the equivalent pipe. So thank you for this session. Thank you.